Hello friends, welcome to the Zeta Online Science Academy. Today we are going to discuss lecture number 4, part 2 of chapter 2 O level series 5070 according to the syllabus 2023, 24 and 25. If you are new at our channel, then kindly subscribe our channel and press the bell icon so that you get the notification of every video. So let's start the video. In this part of the chapter, we will discuss about atomic number and periodic table. According to the course content, describe the structure of the atom as a central nucleus containing neutrons and protons surrounded by electron shells. What is atom? As we discussed in the previous lecture, the smallest particle of an element that can take part in a chemical reaction is said to be an atom. If we consider atom is of spherical shape, then the center of the atom will be called nucleus. In nucleus, two particles which are fundamental particles of atom, which are protons and neutrons, are present. While outside the atom, the electrons are present in specific orbit which are known as shells. The size of nucleus is very small as compared to the size of atom. As we can see that the diameter of atom is 10 minus 10, while the diameter of nucleus is 10 to the power minus 15. If we divide these two particles, then we get the difference of 10.5. It means that a atom is 1 lakh more times larger than nucleus. A nucleus is 1 lakh times smaller than atom. Here two particles, neutrons and protons, are present. State the relative charges and relative masses of a proton, a neutron and an electron. Protons are denoted by P. They have relative charge 1 positive charge, while neutron has no charge, they are neutral, and electron has negative charge. If we talk about their relative mass is often measured in atomic mass unit or AMU. The relative atomic mass of proton is 1 AMU, while neutron is also 1 AMU, and the relative mass of electron is 1 over 1840 times smaller than proton and neutron. Due to this reason, we neglect mass of electrons when we are calculating the whole atom mass, which is said to be an atomic mass. And, these types of questions are often asked in P1 and P2 exams. What is relative charge on proton, what is relative charge on electron, what is relative charge on neutrons, and also about their relative mass. Define proton number or atomic number as the number of protons in the nucleus of an atom. As this course content also providing us the information that just a moment. The course content providing us information about atomic number. What is atomic number? Atomic number is actually the number of protons in the nucleus of an atom. It is total number of protons in the nucleus of an atom. What is the benefit of atomic number? Atomic number is actually identification of an element. By knowing the atomic number, we can predict the element, because every element has its specific atomic number. Atomic number of two elements cannot be same, never ever. Therefore, it is distinguished property of an element. The second, atomic number also helps us to place element in periodic table, because in periodic table the elements are arranged according to their increasing atomic number. The atomic number is represented by Z. It is often written as subscript to the left side of the element. Carbon has 6 atomic number. Here we will write its atomic number. Nitrogen has 7 atomic number. It means that the number of protons in nitrogen is 7, while oxygen has 8 atomic number. Similarly, fluorine has 9 atomic number, and hydrogen has 1 atomic number. This atomic number is actually number of protons. One thing more I want to discuss here, the number of protons and electrons in an atom are always same. Due to this reason, atom is neutral. Due to this reason, because positive and negative charges cancel their effect with each other and neutron has no charge, therefore atom is neutral. If some electron escapes or enters into the atom, then it surely atom will gain some charge, and at that moment atom will be called ion. I hope this is clear about atomic number. If an element is provided to you, then you can find your atomic number by knowing, by seeing only the subscript of the element. Then about mass number. Define mass number or Nucleon number as the total number of. In the course content, it is also providing us the definition of mass number and Nucleon number. Mass number is also called as Nucleon number. It is the total number of protons and neutrons in the nucleus of an atom. Mass number is helps us to calculate the atomic mass. It is represented by A. It is written as superscript to the left of the atom, just like that. Here carbon has 12 atomic mass, nitrogen has 14, oxygen has 16, and sodium has 23. Here is the formula for calculating atomic mass. A is equal to Z plus N. Here is number of neutrons. A is atomic mass and Z is protons number. In other words, number of electrons or number of protons. What will be the number of neutrons in oxygen, whose atomic number is 8, while atomic mass is 16? By simply using this formula, A is equal to Z plus N. If we have to find N, then this formula will become A is equal to N is equal to A minus Z, because moving Z into this side of the equation will change its sign positive to negative. In this way, by subtracting the atomic mass from atomic number, we can calculate the number of neutrons. 16 minus 8, so there will be 8 number of neutrons in oxygen. Calculate the number of protons, neutrons, and electrons in uranium-235. Here, the atomic number is describing as 92 number of protons are present in uranium, as number of protons and electrons are same in an element, therefore also 92 number of electrons are present. If you subtract 235 minus 92 according to this formula, you can also calculate number of neutrons. I also write this thing below, that number of electrons and protons are same in an atom, that's why atom is neutral. And now the main topic of today's lecture starts, which is electronic configuration of elements and their ions with protons number 1 to 20. Here is the format of electronic configuration. Before writing in that format, we will try to write it in the form of subshell and shell. What is electronic configuration? Electronic configuration is actually distribution of electrons. Distribution of electrons in shells and subshells according to their increasing energy levels is called electronic configuration. Now here are two terms, shell and subshell. What is meant by shell? Shell is actually the energy level or orbit of electron around the nucleus in which electrons are present. The shell number starts from 1. Shell number start from 1. I am saying this because the subshell number starts from 0. Shell, the first shell is K shell, and the second shell is L shell, third shell is M shell, and the fourth shell is N shell. Here I simply try to draw it. This is nucleus. This is first shell, which is nearest to the nucleus. The second shell, which is further, and as we move further, as the shell number increases, it also moves further from the nucleus. Here's shell number. And the next thing is how many electrons are present in each shell. The number of electrons in each shell can be calculated by this formula, 2n square. Shell number is denoted by n. By putting simply value of n, we can calculate the number of electrons in each shell. Let's try. K has shell number 1, 2, 1 square is equal to 2 into 1 is equal to 2. Therefore, 2 electrons are only present in K. While for L, we can simply try 2 into 2 square is equal to 2 into 4 is equal to 8. 8 electrons are present in K. Similarly, you can calculate the number of electrons in M and N shell. 32. How many? Here is a question which improve your concepts more. How many electrons are present in an atom whose second shell is complete? Before answering this question, I want to clear one thing. The first electrons will fill this shell, K shell, and then L shell, and M and N. According to the increasing energy levels, as they are moving away from the nucleus, their energy increases. So first the lowest energy shell is filled. and then we move further. How many electrons are present in an atom whose second shell is complete? It means that the first shell of this atom is compulsory completed, because without completing first shell, electrons of an atom cannot move towards the second shell. Now we can simply calculate the number of electrons in first shell. Only 2 electrons can be accommodated. The second shell of this atom is also complete. Therefore, the number of electrons in this atom will be 10. I hope I make this clear to you. Is 10. Now we see something about concept of subshell, and then we will talk about electronic configuration. What is mean by subshell? Subshells are actually region within a shell. It means that atoms are present in shell, and then shells are divided into subshells. We are specifying more the place of electrons in a shell. After subshells, we also divide it into orbitals, but that is not included in our topic. The region of a shell where electrons are likely to present. The number of subshells starts from 0. The subnumber of subshells are also denoted by L. The K shell has only one subshell, which is S, because it is the first shell and it is the lowest energy shell. The second shell, L, it has 2 subshells, which are S and P. These are names of subshells. In M shell, the 3 subshells are present, S, P, and D. In N subshell, 4 subshells are present, S, P, D, and F. If I talk about the numbering of shell, K has its N value 1, L 2, N3, and N4. While similarly, S has 0 L value, P has 1 L value, D has 2 L value, and F has 3 L value. I am describing you this numbers of L because it will help you to calculate the number of electrons in a subshell. You can simply calculate the number of electrons in a subshell by this formula: 2 into 2L plus 1. S value is 0. Put this value here and you can see 2 into 0. 0 plus 1, 2 into 1 is equal to 2. It means that only 2 electrons can reside in a subshell. Here I describe. Now you can you can have an idea that why K shell have only one subshell, because in K shell the only electrons accommodate are 2, and these 2 electrons can be accommodated in S subshell. Therefore it has only one subshell, which is S. If we talk about L has 8 electrons, has the capacity to accommodate 8 electrons. Now we will see 2 electrons will come in S, and the remaining 6 electrons will come in P subshell. You can also calculate by using this formula the number of electrons in P. 2 into 1 plus 1 is equal to 2 into 2 plus 1, 2 into 3 is equal to 6. Similarly, you can also calculate the number of electrons in D, which are 10. You can also calculate the number of electrons in F, which are 14. Similarly, you can see that N has 18 number of can accommodate 18 number of electrons. Therefore, 2, 6, 8 plus 10, 18. Similarly, F has 14 number of electrons, D has 10. P has 6, SN2, therefore 32 electrons are completed. Now you also have an idea why K has 1 subshell, L has 2, M has 3, N has 4 subshells. Did you notice one thing more, that the shell number and subshell number and the total number of subshells are same? It means that N is equal to number of subshells in an atom also. It means that if an element has one shell, it means that only one subshell is also present in it. If it has shell 2, then 2 subshells are present. In shell 3, 3 subshells are present. In shell 4, 4 subshells are present. Now I am describing you simply a trick for electronic configuration. Simply write down in this way. I am writing it again. I rotate it for K. It means that for first shell. Therefore, this number before the subshell indicates the shell number. For first shell, only 1s is present. For second shell, 2s and 2p are present. Oh, sorry, second shell is F. For third shell, 3s and 3p and 3d are present. For fourth shell, 4s, 4p and 4d are present. And similarly, N has 4s, 4p, 4d and 4f. Now, what is trick? Because electronic configuration of only first 20 elements are given in our syllabus, therefore we also stuck on this. Now put an arrow like that and start writing the element from behind the arrow, from the tail of the arrow. 1s, 2s, 2p, then 3s, then 3p, then 4s. The electronic configuration of first 20 elements completed here. Like you can see that I wrote here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 2, 2, 8, 10, 8, then 2, 20. And only 20 elements electronic configuration are asked in our syllabus. Now, which pattern are said to write electronic configuration in our syllabus is that write it with number of shells. Not, there is no need to rewrite all these subshells, but you have to write if you want to understand it. 2, then we will write shell 8 and then 3 shell 8. You can also say that why electrons after 3p it should come to 3d and then it goes into 4s, but this is due to transition elements and we will describe it in later chapters. Now your task is simply just simply to learn how to write electronic configuration. I hope this is clear now how to write electronic configuration. We also do some practice so that we can learn easily all these things. Just write electronic configuration of carbon 6, nitrogen 7 and aluminium 13. Only 6 number of electrons are present. It means that 1s2, 2s2, 2p, 2. Here 6 electrons are completed. 4 and 2. We can simply write the electronic configuration of carbon in that way, 2 into 6. And if we write the electronic configuration of nitrogen, it will be same 1s2, 2s2, 2p, 3, 2n2, 5. If we wanted to write the electronic configuration of Al13, I am going to write it here: 1s2, 2s2, 2p6, s6, 8, and then 210. It means that 3 electrons are present, 3s2, and then 3p1. 3s2, 3p1. Now you can write it according to the format needed: 2 into 8 into 3 simply. That is 13. Also, it is also asked in our syllabus that also write the electronic configuration of ions. What is ion? Before writing is electronic configuration, it is necessary to understand what is meant by ion. Ion is an atom having positive or negative charge on it. If it has positive charge on it, it is said to be cation. If it has negative charge on it is said to be anion. And anion is formed by losing electron. When an atom loses electron, cation is formed, and when an atom gains electrons, anion is formed. Why this happens? You already know that in atoms the number of protons and electrons are equal. In atom, the number of protons and electrons are equal. If number of protons and electrons equal, if we are, that's why atom is neutral. And here zero charge on the atom, zero charge on atom, because its number are equal. If we remove one electron from here, then the number of positive charges will increase. That's why a positive charge will come to an atom. Simply, if I give an example of sodium, it gives an electron and a positive charge comes on it. Why positive charge comes? Because one electron now is less than the proton. This positive charge will show us how many electrons are lost from an atom. What positive charge is showing? Positive charge is showing how many electrons are lost from an atom. If Na positive, the atomic number of Na is 11, and Na positive indicates that it has only 10 electrons. And when we comes towards the anions, similarly protons and electrons are equal. If one more electron is added to the atom, the electron number will increase, and if electron number increases, then negative charge will come on an atom, and negative charge indicates that how many electrons gained an atom. If I am saying O2 negative, atomic number 8, it indicates that 8 electrons were present in oxygen O, and here 2 negative is also indicated that 2 more electrons are added in it. Therefore, the total number of electrons will be 10 in O2 negative. I hope now you have an idea how to write electronic configuration of anion, and what this positive charge indicates and what this negative charge indicates. Write electronic configuration of Cl negative. Cl negative, it means that already 17 electrons are present in chlorine, while negative charge indicating that and now it has one more electron. Now we will simply write 2 into 8 into 8. 2, 8, 10, and 8, 18, which is equal to 80. You can also write that in this way: 1s2, 2s2, 2p6, 3s2, 3p6. I simply wrote it according to the according to the pattern asked in your exams, in your syllabus. Or 2 negative, simply we can write 2 into 8, 10. And here Na positive, the positive charge indicating that total 11 electrons were present in sodium, but it has lost its 1 electron. Now there are only 10 electrons are present in sodium. Therefore, its electronic configuration will also be 2 and 10, or 2, 8. Now you have an idea about electronic configuration. Here some questions also included in 2.2 related to the periodic table. We will also discuss about periodic table in next chapter very detail. State that group 8 of periodic table, which are noble gases, have full outermost shell. What is meant by group in periodic table and what is meant by period? These two terms. For explaining these two terms, I want to show you people the periodic table. Here you can see the periodic table. This periodic table will also provided to you during the exam. Here the vertical columns, this vertical column are called to the groups of periodic table. Vertical columns are called groups of the periodic table, while these horizontal rows, the horizontal rows in the periodic table are said to be periods. These vertical columns are said to be groups, and these horizontal rows are said to be period. What is our question? He is asking in our question the group 8, which are said to be noble gases. They have complete outermost shell. Here is helium. Its atomic number is 2. You can simply that its outermost shell is complete. Here is neon. You can also see that its outermost shell is also complete, 2:8. Here is argon. You can also see that its outermost shell is also complete, 2:8. 2 into 8 by simply writing electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s. 4s will not come, so we will write 2 into 8 into 8. 8 outermost shell is complete. Now come to our slides to discuss something. This is last group of the periodic table. Noble gases have most stable electronic configuration among all the elements present in periodic table. Therefore, they are less reactive. We will discuss more it in periodic table, and we will also discuss the properties of noble gases. Here, outermost shell is also valence shell. The valence shell of noble gases are complete according to the doublet rule and octet rule. According to the doublet rule and octet rule, it means that total 2 number of electrons or 8 number of electrons should be present in the outermost shell of an atom for gaining stability. In other words, if an atom wants to get stability, he has to attain the electronic configuration of noble gases. we will discuss how elements gaining stability and more terms like that in next chapters. Here you also have to memorize that the valence shell of noble gases is complete. The second term is the number of outer shell electrons are equal to the group number from 1 to 8. From group number 1 to 8. Now have a look at periodic table. See, now you can see that these vertical column I described you are called groups. This is first A group, this is second group, this is third group, this is fourth group, this is fifth, this is sixth, 7 and 8. All these groups are in terms are said to be their B parts. Now in modern periodic table they are assigning also group number in English 3, 4, 5, 6 and 8A is said to be 18. Now is saying that the group number this is group 1. Group 1 indicates that all the elements have only one electron in its outermost shell or valence shell. The group 2 is showing here only 2 electrons are present in its valence shell. The group 3 is indicating that 3 electrons are present in its valence shell. The 4 group is also saying 4 electrons are present. Nitrogen is saying fifth group is saying 5 electrons are present. Similarly, up to the 8th, we can also check. Here is magnesium. The atomic number of magnesium is 8. We can write it as electron 2 into 8 into 2. Now you can see that only 2 electrons are present in magnesium because this is present in group 2. Similarly, if we write about beryllium, here 4, 2 into 2, it also indicating that 2 electrons are present in outermost shell. This was the question and I hope you are clear. The last one is number of occupied electron shells is equal to the period number. We discussed that the outermost number of electron indicated by the group number and the number of shells, total how many shells are present in first period. Only one shell. K is present in first period. You can see that in first period only 2 elements are present, that are hydrogen and helium. Therefore, in first period only one shell are present. In second period 2 shells are present. In third period 3 shells are present. Similarly, in seventh period 7 shells are present or electrons are present. I hope this is clear. Now you have an idea what are groups, what are period, and what period indicates and what groups indicates. Now let's do some practice questions so that we can easily solve a question in exam. The ion Q21 has 3 complete shell of electrons. What is Q? Now write an electron of 2 into 8 into 8. It means that why it is 2 positive, it means that this element has lots, it's 2 electrons, so we will also write 2 here. Now calculate total number of electrons. 2 and 20. 20 electrons, it means that 20 protons are atom, and if 20 protons are present, 20 will it's the atomic number, and the atomic number of calcium is 20 and our correct option will be calcium. Now move toward the second question. The second question is the symbols of two ions are shown. Here two ions are given. What statement is correct? The first statement is showing the fluoride ion contains more electrons than the sodium. Here is comparison of electrons, protons, and neutrons. We can simply see in this here protons, protons, electrons, and neutrons and neutrons. Fluorine has 9 protons and sodium has 11 protons. It means that same number of protons does not included in an element, so our option D will be incorrect. If we talk about number of electrons, 9 and 1 it gained 1 electron. It means that 9 plus 1 is equal to 10. Total 10 electrons are present in F negative. And here we can see that 11 minus 1, because it has lost 1 electron. This is showing by the positive number. 11 minus 1 is equal to 10. That they both have same number of electrons, and this is our correct option. The two ions contain the same number of electrons as each other. You can now move towards. You can also tell me the other option, but I am moving next. The table shows data for some particles. Here sodium ions are present. Here total number of protons are present. Protons, Nucleon number, which is also known as mass number, number of protons, number of neutrons, and number of electrons are given in 3 elements. What are the value of W, X, and Y? Where W is present. Here he is asking us about the number of proton, number of neutrons present in sodium ion. Nucleon number of sodium ion is 23 and its proton number is 11. It means that 23 minus 11 is equal to 12. It means that the value of W is 12. So our correct option will be C, or it can be D. It can be D. Here in these two options we will find our option. Find the value of X, where X is present here. Fluoride ion. Fluoride ion, it means that fluorine has gained its 1 electron. What is why we are calling fluoride or chloride? We will discuss the naming of these ions in chapter number 4, ionic bonds, or yes, we will discuss in ionic bonds. Fluoride, it means that fluorine 9 electrons are present in fluorine and he has gained 1 more electron. Therefore total number of electrons are 10. Here is also 2, here is also. So our deciding decider will be magnesium. Here value of Y, he is asking about number of protons. Number of protons are equal to the atomic number or proton number, which is 12. So our correct option will be C. I hope this is clear now. Now move towards the next question. The next question is element X can be represented by symbol X6 and 14. What statement about atoms are X are correct? X, by seeing that we can see that here asking proton, neutron, X, we can write it electron, proton, and neutron. The element has 6 number of protons. It means it has no positive or negative charge on it. Therefore, it will also contain 6 number of electrons. And if its atomic mass our mass number, our nucleon number is 14, then it will contain 8 number of neutrons. It has 6 electrons. This statement is correct. It has 8 protons. This statement is wrong. It is an isotope of carbon. Yes, this is also correct because atomic number of carbon is 6. It is an isotope of, this is wrong. So only 1 and 3 statement is correct. Now move towards the next question. What is Nucleon number of the isotope of uranium 92 and 235? I also described you during the lecture that Nucleon number or mass number is written as superscript on the left side of the atom. So 235 is Nucleon number of isotope uranium. Here is one question from paper 2 which we solved. Atom and ion contain protons, neutrons, and electrons. Complete table 2.1. We also draw this table during the lecture. It has neutron has 0 charge, electron has -1 charge. Relative mass of proton is 1, while relative mass of electron is times then the proton. All this was about I think this no more question. Yes, no more question. This was all about today's lecture. We will continue 2.3 in our next lecture. If you are new at our channel, then kindly subscribe the channel. If you have any queries related these topics, you can ask me in comments. You can, if you also want to join free O-level session, I will I will put the link in of Google form in description. You have to fill that form, and good luck having the opportunity of free O-level section.